Okay, hello. I'm going to teach you a little bit about how the chemical reaction that we're going to be studying happens. So I have in front of me the things that you have in your little kit. So the red spheres are oxygen atoms, and they have two holes in them because they can make two bonds. And the hydrogen is got one hole because it can only make one bond. So we're going to start with hydrogen peroxide. So hydrogen peroxide has a hydrogen connected to an oxygen. The oxygen is connected to another oxygen, and then that is connected to a hydrogen too. So this is hydrogen peroxide. Another way of saying this is H2O2. Because there's two hydrogens and two oxygens. Okay, so I'm going to actually make two hydrogen peroxide molecules. So you connect the two oxygens, you connect the two hydrogens, and you make two hydrogen peroxide. Okay, now the thing that's going to be speeding up our reaction is something called an enzyme. And in this case, we have peroxidase. Excuse me. So peroxidase is an enzyme, and enzymes speed up chemical reactions, and they're really actually very large protein molecules. And so this is really not at all to scale, because in reality the enzyme would be way bigger than the hydrogen peroxide. But it's going to have to work the way we have it. So what happens is the hydrogen peroxide is called the substrate. And it fits inside the active site of the peroxidase enzyme. And what that enzyme does is it's going to kind of tug on the bonds a little bit to make it so that it's really easy to break. So what I have to show you how that works is this cool flippy ball. So this ball can go from blue to pink. And so think about this as being like hydrogen peroxide, and the enzyme is straining on the bonds. And so it makes it really easy to flip to what the hydrogen peroxide turns into, which in this case is water and oxygen. So here's hydrogen peroxide. It's pretty stable. It doesn't go anywhere. It doesn't change. But if you put it in an enzyme, it makes it really unstable. So it can really easily, quickly change to products. So here's the hydrogen peroxide again. It goes into the active site of the enzyme, and it's going to strain on the bonds. And so what's going to happen is that it's going to break. And two molecules of hydrogen peroxide end up getting broken. And then what happens is they get rearranged to form water and oxygen gas. So the water is easy. You just take the broken hydrogen peroxide and stick another hydrogen on here. And that's water. Two H's and an O. And you could do that on the other one. There you go, there's another water. So now we have two waters. And now we have two oxygens left. And so that's going to form oxygen gas. Now oxygen gas has two bonds that hold it together. And these little single bonds don't bend. So in order to connect the two oxygens, I actually have to use these bendy bonds. Okay? And so this is oxygen gas. So the oxygen that you breathe in the air is this molecule, oxygen. So it's O2. So you end up, here are your products. You have two waters and you have oxygen gas. Now this is a gas, so this is going to make bubbles. So in our chemical reactions that we're going to do, you're going to use the enzyme peroxidase, which is present in almost all cells. So we're going to use potato peroxidase and watch it form bubbles. And then we're also going to use yeast peroxidase and watch it form bubbles. But either way, it's the same enzyme that turns hydrogen peroxide into water and oxygen gas.